Okay, this is Mr. Elmhorst. We're going to take a look at the Intro to Ratios exit ticket. So first thing, ratio is just going to be a comparison of two numbers or quantities. So for example, in a classroom, let's say you had three boys and four girls. That would be a ratio, just as a comparison. But then if you added these up, then it would be, let's say, three boys out of seven students. So this is going to be a part-to-part comparison, part to part, where it's both students, but then you'd have part to total or part to whole, where you have boys being compared to all the students as a comparison here. So I'm going to go ahead and do the drop down screen. Oh, it's not letting me do it. Here we go. So a ratio is a comparison, two or more quantities. So ratios can be written in three different ways. So you can do, for example, 3 to 4 as far as boys to girls, or you could write it as 3:4, but then you'd also do it as a fraction as 3/4. So it'd be words, symbol, or colon as a fraction. So the ratio of squares to stars, so when you're is part to part, squares and stars are both shapes, and they compare two different parts. The ratio of squares to all the shapes, we're going to call that part to whole, where you part to total, because it compares a part to the whole group of shapes. So birds to animals would be part to whole, and birds to reptiles would be part to part. Or let's say you're talking about all of the animals, it'd be birds out of all the animals, or part to total, or it'd just be talking about birds and reptiles. So ratios are equivalent. Ratios are going to be equal if you could use them to multiply or divide both of the quantities. So what does that mean? So using that example, 3 to 4, and let's say we did 9 to 12. So in one class, let's say you had three boys for every four girls. Well, if you had 9 boys, then you have 12 girls with the same ratio. But they're going to be equivalent if you could multiply by the same number, and you would have the quantities that would keep them by the same. The numerators and denominators must be multiplied or divided by the same amount to make them equivalent. The numerators, the top and bottom of the fractions, must be multiplied to make them equal. So the ratio of squares to stars. So we have 1, 2, 3, 4, 5, 6, and then stars, there's 9. So the ratio would be 6 to 9. Part to part ratio. So we're talking about squares and triangles. So there's 2 squares and 4 triangles. So that's total shapes, that's total shapes, that's total shapes. But part to part would be squares and triangles. Now, part to total is different. So there's 1, 2, 3, 4, 5, 6 total shapes. So the only answer that would make sense is 2 circles and 6 shapes. Which ratio is equivalent to 2 to 5? So we set up the ratio as a fraction and see what's equal. If we multiply by 2, let's see what we get. 4 to 10, and that one does check out. So 2 to 5 would be equal to 4 to 10. And we use multiplication here. 5 times 5 is 25, and 7 times 5 would be the answer here.